Welcome to Carlton's Math Corner. Today we're going to continue our study on inequalities. At this time, please make sure that you have a notebook, something to write with, as well as your vocabulary packet. Today our target is I can solve and graph compound inequalities. First of all, I want to talk about what are compound inequalities. Basically, they are two inequalities that are combined together. So we actually graph them on one number line, okay? So here is an example of a compound inequality, and I want you to look at the steps that's happening, because here's one inequality. Look at the step that's happening, and then over here, look at this inequality. What do you notice? Well, I notice that the inverse operation is happening on both of them. For instance, this inequality, the inverse operation is dividing by 12 because it was multiplying by 12 before, so the inverse is division. And so our inequality is n is greater than 5. Then on the other side, I notice that the inverse of minus 4 is plus 4. So, and then instead of, 12 times n, now we did the inverse and we divided by 12. And so our inequality is n is less than or equal to 1. So notice these two inequalities, when you plot them on a number line, okay, so pretend you're like plotting them separately, but you're putting both of them on the same number line. If I plot n is greater than 5, first of all, this is greater than 5, so that means it's an open dot on 5, and it's greater than, so I'm going to the positive direction. So I'm drawing a ray into the positives. And then n is less than or equal to 1. I need a closed dot on 1 because I need to include 1. And then it's going to the left because it's less than. So I need it to go to the negatives. What do you notice about this graph? Yeah. Do you notice that these two go in the opposite directions? What does it mean when it's empty in the middle? Yeah, this emptiness in the middle basically is saying that these solutions, well, these numbers in between 1 and really close to 5 is not, they're not included in this as solutions. Like they are not solutions for these two inequalities, okay? And so that's why it's blank. Now these rays show the solutions that would work for both of these inequalities. And we call this, when they're going opposite directions, we call it a union. And we use this little U as a symbol stating that these two have a union between them. So I could actually put a U in between this inequality and this inequality, and that states that they have a union between them. Okay. Now, what do you notice that's different about these two inequalities? Yeah, these compound inequalities, actually they started off exactly the same. They solved with the inverse operation. So, instead of minus 9, we did addition. And then instead of multiplying by negative 10, we divided by negative 10. Now, remember though, when you divide by a negative or multiply by a negative, the symbol switches. So look what happens. The symbol did switch on this inequality. So we have x is less than or equal to negative 2. Now if you look over on this side, opposite of multiplying by negative 11 is division. So we divide. And, well, the symbol also flipped on this one. Now both of them have a line underneath, so they're both are or equal to. So that means that we have closed dots on both of them. So if I start off with a negative 2 and I put a closed dot on it, and it says less than, so I have to go to the left. Now on this one is actually greater than, so I have to go to the right. So I put a dot on -8 and go to the right. And what happens is they have an overlapping part in the center. And this is an intersection. And we use an upside down U to show an intersection. Now, where it intersects, these are the solutions that would fit for both of these inequalities. So anything on the outside, where they don't overlap, those are not solutions. Okay, and so intersections, there's an overlap. That's why it's called an intersection. It's where those solutions intersect with each other. Okay, so now what if I have one that looks like this? Well, first of all, I can break this up into two. Okay, this is a compound inequality and I can break it up. So if I start off, and I want you to actually, if you have a highlighter, this would be a great time to highlight the center part, this expression, because this center part is what is shared between both of them. Okay, so meaning this -7n minus 12 will go with the -3 and it will go with the -26. And so I'll show you how this looks. So it goes -33. And do you notice that the mouth is facing the -7? So that means, and then the point is facing the -33. So that means I need to actually keep it that way. I need to keep it as the mouth faces the center part, and then the point faces the -33. Okay, and then on this side, I'm going to do the same thing. I'm going to do -7 minus 12, but this time the point faces the center expression, and the mouth faces the -26. So the point faces the center, and the mouth faces the 26. So these are my two inequalities that I need to now solve. So the first thing I have to do, remember, I need to get the -12 by itself, right? So I need to add 12, and I need to do that on both sides just to make sure that it's balanced. And so what happens is all I have left is -7 is greater than or equal to, and in this case we're really subtracting these two because one's negative, one's positive, so it's -11. Okay, and then how do I get rid of that -7? Divide by -7. And so I'm going to do exactly that, and I'm going to divide actually both sides. So I'm going to take and I'm going to draw a line under this one for division and a line under this one, and I am going to add -7 and -7. And what happens is I actually get a fraction I get a fraction for my answer on this one. But if I change this to, a mixed number, then it'll help me to graph it, because my answer is, and remember I divided by a negative, so that means I got to flip the symbol, and we get 11/7. Or we can say that this is also the same as 1n, if it will let me type here, 1 and 4/7. So it's a little bit, it's between basically 1 and 2, positive 1 and 2. Now if you go on the other side and we do the same thing with this, we're still adding 12, adding 12, adding 12, and so we get -7n, and which is less than, and again we need to subtract because one's negative, one's positive, so we get -14. And then we're going to divide again, because that's the opposite, the inverse. And so we're dividing by -7. And we get +2. So this one actually turned out nice. N, and the symbol flipped because we divided by a negative again. We get +2. So if I want to graph these two inequalities, I am actually just going to put a couple numbers on here. I'm going to put a 0, and then I'm going to put a 1, and I'm going to put a 2, and then I'll put a -1 over here. Now, when I graph this, first of all, this one is 1 4/7, so it's going to be, you know, about right here, and it's a closed dot only because of this or equals to. And this one has a ray that will be going off to the left. And then this one is greater than 2. And so it is an open dot on 2, and it's greater than. So it's going this way. It's going off to the positives. So what kind of compound inequality is this? Yeah, it's a union. So actually I can put these two are a union between them, meaning they have solutions that are greater than, going off into the positives, but they also have some solutions that are going off into the negatives. And then they have a few solutions right here that don't, or I'll just say they have a few numbers, a few values there that are not solutions for both of them. Okay, what I would like you to do is I want you to try a couple problems. One of them is an intersection and the other one's a union. Thank you so much for joining me at Carlton's Math Corner, and I look forward to meeting with you again. Have a great day. Bye.